Welcome everybody, thanks for joining. My name is Resul Altinkilic, project manager for Resul, and I would like to show you the next steps of the OCP cooling version 2, or let's say in the Door heat exchanger group. What we are doing now, what we did, I showed it the first time in San Jose, and which steps we done till now. I'm working in the group of Jacob in the Door heat exchanger group, what I mentioned previously. And at first I would do just to give you an overview about the functional principle. A door heat exchanger is not a rocket science. This is easy as I describe it now. The cold air from the room is getting sucked by the servers. The air is getting heated up by the servers by the powerful GPUs and CPUs. The hot air is getting pushed to the heat exchanger, and the heat exchanger is cooling down the hot air. Our heat exchanger, what we have, is running passive by water. Passive means no fans, no electric power consumption. In that case, in the passive case, that means we have a complete data center acts as a cold layer, and we have a homogeneous data center, homogeneous temperature in our data center. On the right side, you can see the traditional connection points. Traditionally, or let's say mainly, our customer are using the connecting points from the top. But if there is an existing data center who doesn't have a raised floor, it is also possible, or let's say we are working on a possibility to make the connecting points from the top. But the problem what I saw here is, in case of any leakage on the top, it could be that liquid is going down and could damage potentially the server. And also you can see a top view of the Resul heat exchanger functional principle. It is simple as it is. The cold air is running through the server, heating up and going through the heat exchanger, and the cold air is going back to the facility again. But we have some requirements from special customer who said, okay, I have, for example, a Cisco switch. Then we can use air buffers to, let's say, to redirect the air from left to the right. That's also no problem. As I mentioned before, we are working on a passive solution. That means no fans, no electrical power consumptions on that side. Yeah, regarding water connection, John also mentioned the 1-inch connection points. Resul is using a DN25, what is 1 inch. We are did in the past for our traditional racks from the bottom, but for the current development, we are doing it that it is flexible, that it can be done as the specification wants. We can do it from the top and also from the bottom with those connections. And currently, we are working also with the data center facility group that we are getting harmonize these standards. For example, that the data center facilities are using one type of thread. For example, 1 inch, that if there is getting used immersion, that they can use also the thread that doesn't need to have to change. All right. The first 3D module of the Resul heat exchanger, what we designed, as you can see, it's OCPREG version 2 with the Resul heat exchanger. We developed a special adapter frame, a special sealing, what is also requirement in the specification. The cooled output range is from 10 kW to 20 kW. And the thing is, hotspots are getting eliminated without changing any existing cooling environment. And also, we have, as this specification requested 300 degrees hinged doors that enables you to have access to your, let's say, IT gear in your IT rack. And also what we define in the specification is a service door. On the right you can see the service door that enables you, in case of any leakage or in case of any damage from the heat exchanger, you can rework it, you can change it completely out. It's definitely not a big deal, but it's also have big benefits to, let's say, have such kind of service doors. And here you can see the Resul heat exchanger in a live case, how we, let's say, put it on in our IT rack. Also some product information. The door heat exchanger is getting developed under the OCPREG version 2 specification, and now we are focusing to develop it for OCPREG version 3. As John mentioned, 600 is the same. These are also the same, but what only changes are the slightly height differences. The empty weight of the door heat exchanger will be around about 80 kilogram. The water inlet temperature 50 degrees Celsius. Room outlet temperature, that means the temperature after the door, it will be around about 24. Yeah, coming to the special, or let's say specification requirements. So monitoring, we are able to, let's say, monitor these temperature values. For example, monitoring inlet temperature, inlet rack temperature, or let's say the temperature outside from the door. We can also monitor the water inlet temperature and then also the water outlet temperature with a Resul CMC. CMC stands for Computer Multi-Control. And also the possibility to monitor the valve position, it is also given. So that means we can only control it. We cannot, let's say, set it. We can control it in how much percentage it is open. For example, 150 or 75, even what is requested in the data center, or let's say on the customer side. As John mentioned earlier, we need to, let's say, harmonize those standards with all the ACS group and also with the data center facility group, together with the rack and power, so that we have a harmonized specification, that we can develop the product easy as requested. So, at least I would like to call to action. I would like to invite you for the weekly calls and also invite you to work together in the OCP community. And thanks to you for joining. Wish you a nice day in Amsterdam. Have a nice weekend. Thank you. Any questions so far? Yes, Rolf.
You specified temperatures.
Yes.
For the water, 15, 24. What is the background between these for these temperatures?
So this is, let's say, this is based on our experience. What we did, let's say, for where I had it, I think here. Yeah, this is, let's say, based on our experience, what we did in the past, 50 degrees Celsius. But yeah, if there's other temperature on the customer side, we need to, let's say, a little bit modify.
But is this related to the kilowattage? Because with the kilowatts that were mentioned,
yeah,
I would assume temperatures of up to 30 degrees or 28 at
you
the
mean,
very
you mean water inlet temperature?
Yes.
Yeah.
Is still fairly acceptable in many locations where radar coolers are used. Is that something that?
Yeah, of course. You're completely right. But I'm only, let's say, put it out what we have in our traditional specification, or let's say in our what we are used in the past.
So is this being part of the requirement for this setup, or is this just an example?
It's not a requirement. It's just an example.
All right,
it's just a recommendation. Or
thanks.
Yeah.
So hello.
Hello.
The power output, the heat dissipation, you took the 10 to 20 kilowatts. For which delta T did you put it out? Is it for the 9 delta T of 9 Kelvin over there, or what was the basic fundamentals for your rollout or engineering work?
So basically, that's a question what we didn't talk into the community, but based on the requirements, I can give you, let's say, further information. You can visit our booth. Then I have a detailed list regarding delta T and other technical specification. We can talk further on that.
Okay, thanks.
You're welcome.
When we did testing in backdoor heat exchanger, we saw a phenomenon in the top of them. If you put the switches on the top, you got turbulent zone, and the temperature raised really high in that zone. It was even dangerous for the switches. Have you seen that in your testing, or have you dealt with that problem?
Currently, we never faced that problem. It is the first time that I hear about that. So, if you can give me more, let's say, more detailed information, I can, let's say, talk with our engineers if they faced any of that phenomenon that you mentioned. All right.
Okay, any other questions? Okay, thank you, Resul.
Thank you.